In this session, we will understand the various ways to connect 7-segment displays to a microcontroller. As an example, we will consider 8051 as the microcontroller, and for this discussion, we will limit ourselves to 3 7-segment displays. They can be anything, but let us start with something. The signals involved in connecting 7-segment displays to a microcontroller are signals, the first signal is the segment data lines, So, these are 8 7 segments plus decimal point. Second is the digit select lines. Now, these may be dependent on number of digits. We can write temporarily as 3 digits. So, we can write down depends on number of digits. And one more thing that will govern the way in which we connect these signals is whether the display is common anode or common cathode. So, these three things will decide how do we do the connections. Now, there are various ways of doing this. So, what are the varieties? First, we select, say the display can be common anode or common cathode. This is one variety. Then the segment data can be active high or active low. Then digit select lines can also be active high or active low. So, based on these three things, we will start drawing some diagrams which will illustrate how do we do the various connections. So, let us take the case of common anode first. So, we start with common anode display. So, when we say common anode displays, then if we at all draw this display as a box, then we draw here common, and somewhere the power must come inside this from the common signal. It is a common anode. So, current must go inside this. So, this should be the direction of current, common anode, and the segment lines will be like this. So, they will be named as A, B and so on up to decimal point, and the digits can be any number of digits. Right. And all the A segments of all digits will be shorted, made common. All the B segment lines of all the digits are connected together. Similarly, all rest of the segment data lines are connected together. So, all these 8 lines are in parallel. So, ultimately we get only 8 lines up to the microcontroller. So, these lines will go to the microcontroller. So, we have a microcontroller and we have some lines of the microcontroller for digit select lines. These are the digit select lines, and this is the segment data lines. Segment data lines. And now, how do we do this connection? How do we do this connection? We will understand. Right. So, again we try to draw it with a specific case like common cathode display, then segment data, active low, and digit select, also active low. So, how do we do this? Sorry, we had taken common anode first. So, common anode, I will draw one display initially, common anode, then microcontroller, digit select line, it is active low. So, I will indicate it as a bubble just to indicate as active low. This does not have any other indication, meaning active low. Then when this goes low, the display should get power. This is a digit select line. So, how do we do this? We connect a resistor, we connect a transistor, PNP transistor, this we connect to VCC, and the collector we connect to this. So, the power will be connected to the common signal, common anode. So, when this goes low, there will be 5 volt here, nearly 5 volt will be there. Right. So, what about the segment data? Segment data is also active low. So, if the segment data is active low, this I have drawn for one digit, for other digits similar circuit has to be repeated. For example, and this will be connected to right. So, this is the circuit, and the transistor can be any small signal PNP transistor like BC 557. Right. Now, we will talk about the digit segment data lines. So, the segment data lines are, the current is going to come this way, and through the segments it is going to come to this place, and then it has to flow this way. Right. So, this current has to be synced, taken in by the 8051 port lines when it goes low. Now, the 8051 port lines can sync the current. So, we can directly connect these lines without any transistor driver, but we will add only the current limiting resistor. So, this current limiting resistor can be 330 ohms or maybe even 100 ohms depending on the brightness required, depends on brightness. We cannot make it excessively low, very small, otherwise the current will be more. Now, since this is a multiplex display, even though current is high, it is going to flow for a small time. So, that average current will be less than the peak current. Right. So, if it is a common anode display, then the connections will be like this. Like, right. Let us take one more example with common anode, and now we will take segment data active low and digit select lines active high. Segment data active low, and digit select active high. Then how do we draw this? Again the display is common anode. So, common anode. Then digit select line is active high. So, this is going to be high, and when it is high the digit should be selected. So, what we have to do is we have to use a emitter follower kind of thing. So, we have to use a PNP transistor, and this we have to repeat for all the rest of the digits accordingly. Then since the segment data is active low, the same logic as earlier is possible. All right. So, this transistor can be of say 1K or so on. It does not play much part because this is an emitter follower. So, if the input is even directly connected to 5 volt, the output is going to be 4.3 or 4.5 somewhere based on the VC sat. So, emitter follower does not cause any base current to be higher. So, 1K as a resistor is fine, and this resistance can be 330 ohms or 100 ohms based on the brightness required. So, this is the kind of connection for these are not the complete diagrams. These are only illustrative diagrams how to connect. If we want to draw the complete diagram, we have to draw each and every connection and show how the complete circuit looks like. So, these are only illustrative things. Then we take one more example of common anode, and in this case segment data active high and digit select active low, right. So, again we draw the display which is common anode, and the segment data digit select lines are active low. So, whatever we have done earlier, that is use of PNP transistor, the same will be applicable here. PNP transistor. I am going to show you for one digit, for rest of the digit it is going to be the same. The circuit will be duplicated. And so on. Fine. So, what we require now is segment data active high. So, these signals are required to be active high. Now, remember the current will come this way and the current has to go out this way from the segment lines. So, if the current has to go out and this is active high, then it is not possible. So, what we have to do is we have to use the transistors here also. So, let us take this active high line, we have to use a transistor, NPN transistor, and then a resistor here, this is 330 ohms, and similarly for all 8 lines we have to use 8 transistors. So, 8 transistors for 8 lines. So, this is the way in which we will have to do the connections. Remember, these connections are not complete, these are only illustrative things. How do we do connections? If we want to draw complete circuit, we have to draw the complete diagram. So, complete diagram will involve drawing everything, all resistors, all transistors, all digits, whatever number of digits given, and their complete connections, not dotted lines like this. Fine. So, we will go to common anode again, common anode, and then segment data lines are active high, and digit select lines are also active high. Now, though this case is fine to write, this is not a appropriate case for 8051, because for 8051 or even for many microcontrollers, the IO lines are input and or floating when the power is switched on. And if they are pulled up, the output lines will be high, and if segment lines are high and data lines, digit select lines are also high, then all the displays will show all the digits, all the segments glowing at power on. So, which is not correct. At power on, whatever the instrument it is, the display should be off at power on, and it should be showing the correct message, value, whatever it is, whatever we want to do under the control of software. So, therefore, we do not consider this case as the valid case. So, this is a discouraged case. So, this kind of connections should not be used. Fine. So, common anode connections are over. We will consider now common cathode display. So, how do we draw common cathode display? And the common point will be drawn downwards, common cathode, and the segment lines will be drawn here. So, the current has to come here in, and then total current has to come out from the common terminal. This is how it is. So, the first case, whatever we had considered here, let us take the same case here, active high, segment data, active low. First case was segment and digit low. So, let us take that case. Segment data active low and digit select also active low. So, how do we draw that? So, if the line is going to be active low and the current has to go this way, then it has to be this way. And a small resistor can be added, though it is not required, because again this functions like a emitter follower of PNP kind of thing. Then the segment is active low. So, when this goes low, this has to be high, and that can be done by using a PNP transistor again. So, the diagram is not very good to see right now, but just consider the connections, and later on you may draw a nice looking diagram. So, these resistors will decide the base current, and they can be typically 4.7 K, and these resistors will decide the segment current, and they can be 330 ohms or 100 ohms or something like that. So, this is how we do the connections of first case. Then we go to common cathode, segment active high, digits select active low, so common cathode, segment is active high, segment data. So, it will be driven by a transistor, because a segment cannot source the current for 8051. So, we need to use a driver. Then this should be a resistor of 330 ohms. This resistor is not strictly required, but you can put 1 k as the value. Then same thing should be repeated for all the 7 segments. Right. And the digit select is active low. So, this will be taken as the signal to drive the PNP transistor. So, that when this goes low, the current will flow this way. Fine. So, based on whatever we have studied, the last case, common cathode, we can add the last case. In the last case will be segment will be low and digit selection will be high, and high case we are not going to consider. So, under this situation, what is expected? We will not draw the circuit, we will simply consider segment is low. So, the circuit diagram will be very similar to, let me create one. So, the common cathode display we are studying, and the combination we are going to study is the segment lines are active high and digit select lines are active low. So, the circuit diagram will be like this. The signals are active high. So, active high line cannot drive this. So, we have to use a transistor. The same circuit is added here. And digit lines are active low. So, a PNP transistor will be used. So, this will be 330 ohms and this can be 1 k. Then the last case will be low and high. Common cathode, segment data, active low, digit select, active high. So, under this situation, how the connections will be? Common cathode, segment data active low, then we have to use a PNP transistor, and this has to be 4.7 k for limiting the current, and this can be 330 ohms. Same circuit we are repeating for all these segments, and digit select is active high. So, active high, and when this is high, the current should flow, and therefore, the transistor here must be NPN type. So, this current, this resistor should be such that it will be able to pass the required amount of collector current. So, typically if the segment current is 10 milliampere, maximum current 8 segments, 7 segment plus decimal point 80 milliamperes. So, 80 milliamperes is the maximum current through this. So, if you consider the gain to be 50 or say 100, then 0.8 milliampere is the current required here, 0.8 milliampere. So, typically 1 milliampere. So, this can be near about 5 k. So, this can be 4.7 k. The actual calculation you can do using Ohm's law. This will be near about 5 volt, this will be 0.7. So, this will be 5 volt minus 0.7 divided by 0.8 milliampere. So, that will come out nearly to 4.7 k. So, that is nearest available resistor. So, in this session we considered various ways in which 7 segment displays can be connected. Remember, whatever we had drawn are not the complete diagrams, but they are suggestive connections as to which at what place PNP transistor is to be used, at what place NPN transistor is to be used, and what will be the approximate values of the resistors and so on. If you want to draw a complete diagram, you have to consider the all segment lines and all digit select lines depending on the number of digits.